All right, so to get us back into it here, I posed the question to you, how do I isolate each of the individual faces of my volume? And what you're seeing here is essentially the overall volume, and you notice that it's not subdivided into 6 individual extrusions. That's kind of your first hint. So using the tools that I put together for you here, deconstruct brep, list item, subdivide surface, and divide domain squared, you would think that I'm leading you down the path of breaking this down and individually selecting the 6 surfaces that are on the front face. However, the trouble that you get in by doing that is if I subdivide this, what I wind up with is 19 individual surfaces that I'm going to have to go through and individually select to get the front face. And if I was to increase the number of subdivisions, then I have to go through and increase my number of sliders or panels that I'm, multi-line data that I'm going to plug in order to isolate each individual surface that I've further added every time I modify it. So, what's a better way of doing that? And so I gave you, what? No. I gave you a couple of hints, and those hints were about, the extrusions, right? So I mentioned this particular item is one solid surface. So how do I get the front surface of each of these 6 individual surfaces all at one time? And you do that by using the extrusions that you use to subtract it. These are subdivided. So if I deconstruct brep on those instead, rather than 19 individual surfaces, I get groups of 6 surfaces. Each of those extrusions has 6 sides. And if I go through and list item on that entire list of grouped, or in other words, grafted faces, then I can go through and pick the same side for every single one. Notice how the index item defaults to 0, and you see the back side of every single one of those extrusions is selected. Well, what I'm going to do is put a slider on here from 0 to 5. And move it across until I get the front face. So if I turn this off and I turn my old geometry back off again, now you can see that I've got each of the 6 individual faces. I didn't even need all the ones that I gave you. I know, it's a little misleading. I tricked you. However, we do need it for the next step. And so rather than releasing you to kind of move on to the next step, since it's kind of just a rehash of what we did in primarily the first subdivision, I'm going to walk you through this in order to introduce the next component that I want to release you to try on your own. So I showed you in the original definition that our objective is to generate basically individual panels. So if I go back to what you saw here, let me turn it on for you. Each of these individual 6 faces gets subdivided again. So we can reconstruct the same number of subdivisions from the beginning and just do it again now with each of these individual faces. Oh, sorry, I want to minimize this. And so we can go all the way back here and we can grab this. Divide domain squared, the subdivide surface. We can even grab the deconstruct brep if we wanted to, and copy and paste and pull it down. And then override the connections. We're going to take this as our domain, that is our domain, and then we can turn this stuff off and turn this on. Starting to see how fast this gets, guys? So with this, what I want to, actually let me verify what I want to introduce next and how I want to introduce it. So we've already got the subdivision. Okay. All right. Vector. Yeah, that's how I want to do it. All right, so we're going to have two parts to the next step. We need to think about how we're constructing the geometry itself. So what I'm going to do, or ask you to do rather, actually maybe I should just walk you through this part first and then release you to do the following parts after that. This might be a little too complex to release you to do right now. Unless you want to try it. You want to give it a shot? Okay, so here's what we should do. We need to find the centroid. We need to find the centroid of each of these panels, and I want you to map a vector from the end points, the vertices, the edge points, corner points, to that center point or centroid. Okay, so two things I need from you. I need you to find the centroid, and I need you to map a vector from all of the corner points to the centroid. Think you can do that? I can give you some hints. So this is what I'm going to do then. I'll give you a couple hints. What you're going to need is under vector and vector. I'm not going to tell you which tool. Okay. And then you're going to need tools under surface and analysis. You've seen that one enough. I'm not going to tell you which tool. And then you're probably going to need, are you going to need list item? Let me verify. I don't think so. Yeah, actually you might. Let me see this. Yeah. You probably won't need that. Yeah, you should be able to do it with just pretty much those two tools. In fact, I'll give them to you, and I'll just try and get you to coordinate them. So the tool that we've used to create a vector is called vector 2-point. And it basically creates a vector between 2 points. And then to find the centroid, it's as simple as using area again. Okay, so these are the only two I'm going to give you. What you're going to have to figure out here is how do I map all four corners to the centroid of each of these panels? And I can already see, based on what I have here on screen, a particular condition that you're all going to run into and probably have trouble with. So for this one, since I gave you most of it, I'm going to give you 10 minutes. Any questions? Okay, let's get to it.